In this video, we're going to take a look at problems 4 and 5 of the recent midterm exam. So for problem 4, you're given a set of labor demand and supply equations of 75 minus 6W equals labor demand, and labor supply is equal to negative 10 plus 4W. I've told you to assume that BJSG Ribs, a rib provider in Thatcher, Idaho, is the only employer of moderately skilled labor in the area, but that it functions as a profit-maximizing firm as though it were in a competitive market. The workers that the firm hires understand that barbecued ribs and Dr. Pepper have their own place atop the true food pyramid. And if you know me at all, you'll realize just how true I think that is about barbecued ribs and Dr. Pepper. So first we're going to identify the market clearing wage and quantity of labor for this market. So we'll do so by setting labor demand and supply equal to one another. So 75 minus 6W is equal to negative 10 plus 4W. So 10W is equal to 85, and W star is equal to 8.5. I can now take that value for W star and plug it into either the labor supply or demand equation. I chose to put it into labor supply, so negative 10 plus 4 times 850 equals 24, or L star equals 24. That simply creates a point, an initial point that I can think about on my graph here. Excuse me. Now, in order to go ahead and fulfill the requirement for part B, I need to find the other points for my graphic. I can do that by setting, for the labor supply equation, setting W equal to 0, which tells me the labor supply is equal to negative 10 plus 4 times 0, or labor supply is equal to negative 10. Well, labor supply equal negative 10. That looks to me like it's out here. At negative 10. And then if I set labor supply equal to 0, 0 equals negative 10 plus 4W, or 4W equals 10, or W equals 2.5. W equals 2.5. So if the only thing I know is W equals 2.5, then it's right on the W axis. Do the same thing for labor demand. If W is 0, then it helps me understand the labor demand is 75. And if labor demand is 0, helps me understand that W is 12.5. Excuse me. So I've set my labor demand curve. I've set one of the points of my labor supply curve, but I also set this other point in the middle, so now I have 2 points for my labor supply curve, and I've set my labor supply and demand curve with W star and L star. As long as I note this is labor, this is wage, supply, and labor demand, then I've got a fully articulated model. And that's part B. In part C, I said, okay, if another firm comes into the market such that labor demand rises to LD prime equaling 85 minus 6W, remember that LD was 75 minus 6W, so it's just shifted outwards a little bit, as you can see in my model. So what's that really going to tell us? Well, let's look here for a moment, and it tells us a lot of our story. So if we've got an increased demand, we then are going to equate the new demand and existing supply to get a new W star and a new L star. That W star, or W prime in this case, I'm calling it that just to differentiate it from star, becomes 950 and 28. And I got those by simply setting these equations. 85 minus 6W equal to negative 10 plus 4W. I solved for W prime. I put W prime into either the supply or demand equation, and I have then L prime. But as I look at this, I've shifted labor demand outwards. I've increased the wage. I've increased the workers. I can easily find the intercepts, and I can continue to articulate my model. So at that, I see that I've got 28 people working in this market at $9.50 an hour. And I ask you, how many workers would the firm, BJSG, continue to employ at that wage? and I've said the BJSG's labor demand hasn't changed. Well, if labor demand hasn't changed, it is still 75 minus 6W. But now we have to plug the 950 in for W, and it tells us that we have 18 workers the BJSG will choose to employ. Because remember, they were employing 24. Now the wages went up, they will choose to employ fewer workers. Well, good. How many workers then will the other firm choose to employ? And this is honestly as simple as saying 28, which is the number of workers for the whole market we see here, minus 18, the number of workers that BJSG employs, only leaves 10 workers for the other firm to employ. How would the firm be able to employ maybe more than that? If they offered a higher wage. But I've said that this is a competitive labor market. So they really can't change the wage just in and of themselves. So that's parts C and D of number 4. Item E, I just ask you to go ahead and identify all of this on the graph for me. So go back to the graph. Just give me the new labor demand curve. Give me the new equilibrium values. And that's really all you needed to do there. And I just kind of explained some of that so that we can see exactly what we're looking at with the new intercepts and such. So now question number 5. Question number 5 is a little bit different. We once again have the same firm, moderately skilled workers. 75 minus 6W is labor demand. Negative 10 plus 4W is labor supply. So items A and B here are virtually identical to items A and B here because they're using the same relationships. As you can see by the same scenario playing itself out. I've got the same labor demand curve. I've got the same labor supply curves. I've got the same values as I had here. Everything's virtually identical because I'm using the same equations for items A and B. In item C, I said if the state of Idaho chooses to increase the minimum wage to $10 per hour, how many workers would the firm employ? Well, the firm still has a demand of 75 minus 6W. So if we put that $10 into 75 minus 6W, we get 15 workers. All right, can we think about the same thing with respect to supply now? Well, we could. Labor supply, remember, the labor supply is equal to negative 10 plus 4W. So negative 10 plus 4 times 0, 4 times W, and W is now 10, equals 30. So we have labor demand at 15, labor supply at 30. And with that, we have a scenario that we can finish out the rest of this. So if we have labor demand at 15 and labor supply at 30, then we know we have some mismatch in the marketplace such that we end up with 15 people unemployed. As we look at the graph, notice that we can see this by imposing the wage of 10 in this graph, going ahead and bringing that across to a point where it transects labor demand equation and curve and labor supply, identify these values, and this then shows really the mismatch. It also reveals for us a couple of areas that might ultimately be important. It reveals our area for worker surplus, and it reveals our area for employer surplus. And then finally, it gives us some formation of deadweight loss. And as it does so, we then see some of the problem that this kind of imposition in the market brings. Employer surplus, significantly less. Worker surplus, a lot more. And you might say, well, fine, the employer gets less, who cares? The worker gets more, that's good. And depending upon your perspective, that might be. But what's really important is that total surplus, which used to be this entire area, worker and employer, is now smaller. It's been reduced by this deadweight loss. So we have to represent something about that here as we look at item D. Finally, in item E, what do the results you presented tell us about the market for workers? Well, it says a couple of things. It suggests that firms don't see sufficient value in workers at $10 an hour to hire as many of them as they'd like, which would suggest that we're not getting as much as $10 per hour of marginal revenue product of labor. It suggests that being able to hire a moderately skilled worker, but at $8.50 an hour, that also suggests there might be a surplus of moderately skilled workers in this market. Otherwise, I would think a moderately skilled worker would earn more like $10, $12, or $15 or $20 an hour. I would think $8.50 an hour is a low-skilled worker. There's a lot that you could have said to me here, as long as it made some sense with respect to the overall context of this problem.